So it's quite important to understand the architecture of the warehouse before you carry out the load. Architecture of the warehouse. Why? Because when you do loading, you will understand that without understanding the architecture, it's literally a little bit harder to understand some points regarding the loading, like types of tables, distributions, and whatnot. So we know that the dedicated SQL pool uses, it's a pool, right? So dedicated SQL pool, as the name tells us, it's a pool, which means it's a cluster. And it's a cluster of SQL engines. To be more precise, Azure SQL Database engines. Okay, Azure SQL Database engines. It's a cluster of Azure SQL Database engines. Okay, it operates rather under massively parallel processing, isn't it? It operates using massively parallel processing system. Massively parallel processing. Okay, how? It has basically three units, which means control unit, second distributions, and third compute node units, compute nodes or compute pool, okay. Now control unit, as the name suggests, or the control node or control unit, whatever you want to say, it's essentially the context manager of your query. Context manager of the query, right? So whatever your query is, it looks into your query, parses your query, prepares a relational algebra, domain algebra, parse tree, bind it tree, and all those things for your query, and essentially tries to fire your query on the compute nodes. But you know that you are doing OLAP, online analytical processing, right? How can you do it on a single resource? How could you do it on a single unit? You cannot do it on a single unit. You have to do it in distributed way. So control unit or control node, which is the context manager of the query and does all the relational algebra, domain algebra, parse tree, and whatnot for your query, decides that your query has to be executed in a distributed parallel fashion, because of the volume of the data that it is trying to crunch, OLAP on the high volume of petabyte scale data. So your data is filled into distributions or slots. You can say distribution slots. There are fixed 60 distribution slots in every dedicated SQL pool. Whatever the dedicated SQL pool you have has fixed number of distribution slots in it, 60. Okay, 60 distribution slots in every dedicated SQL pool. So whatever the tables you have in your query, let's say your query has select t1.a, t2.b from t1 join t2 on t1.a equals t2.b. Let's say you perform a join of two tables. Select t1.a, t2.b from t1 join t2 on t1.a equals t2.b. Let's say this is your query. Now you are hitting two tables, table t1 and table t2, and then you are doing an acqui-join on them. So the data of table t1 and the data of the table t2 will be divided into 60 equal parts by the control unit. So let's say table t1 has 60 million rows in it, 60, or let's say 60,000 rows in it. Let's take a little lower number. Table t2 has, let us say, 30,000 rows in it. Okay, 30k rows in it. So they will be divided into 60 equal parts. Okay, so divided by 60 and divided by 60. What is that number that boils down to? So that would be, if you divide it by 60, you get 1000 rows. Okay, 1000 is 60,000, right? So 1000 rows in every distribution slot. In every distribution slot, it will be filled. Distribution slot will be filled in every distribution slot. Similarly here, how much that would be? 500, right? 500 rows in every distribution slot. In every distribution slot. So it's gonna fill those buckets or the distribution slots, whatever you want to say, distribution slots like that. You're gonna fill those many rows in those distribution slots. Okay, and how many compute nodes you have in your cluster, that depends on what? DWU. Depending on DWU, how many compute nodes you have. Here you have 60 slots fixed. How many compute you have depends on DWU. What is the range? You can have one compute node minimum to maximum 60 compute nodes. There is a chart that tells us at 100 DWU, you will have one compute node. At 200 DWU, you will have one compute node, but you will have more RAM. Okay, so there is a chart which we're going to look very shortly, resource limits. But how many compute nodes? Compute nodes are nothing but query relational engine, right? So if we were to just query relational engine, nothing but a query relational engine that executes your query. It can be 1 to 60. Now, depending on how many you have, these buckets, 60 buckets, will be distributed equally within them. So let us say right here compute node, and here write number of buckets to process, number of slots to process in parallel. So when you have one, you can have two, you can have 3, 4, 5. Let's say directly go to 10, right? I'm using it for simplicity. 15, 20, 30, and 60. Let us say these are the compute nodes that you can have. Okay. If you only have one compute node, how many buckets this guy have to process? All the 60 buckets filled with 1000 rows in each bucket from the table T1, 500 rows from each bucket of table T2. So all the 60 buckets this guy has to process. So this is no parallelism, right? There is nothing parallel happening here. Okay, all of the work has to be done by this guy. If you have two workers or two compute nodes, they could say, let me process 30 buckets and you process 30 buckets. So 30 buckets both will process. Correct? Both will process 30 buckets. When you have three, all the three will say 20 buckets. Let's process 20 buckets. 4, 15 buckets. 10, 6 buckets, right? Each one of them will process 6 buckets. 5, 12 buckets each, right? So each guy will process 12 buckets. Correct. When you have 15, 6, 20, 3 buckets, each guy has to just process. When you have 10, 6 buckets, you have 15, 4 buckets each individual has to process. When you have 20 compute nodes, 3 buckets each individual. When you have 30 compute nodes, 2 buckets each individual. And when you have 60 compute nodes, they will just process 1 bucket. 1 bucket, only 60 people doing the work, it will be blazingly fast. Your query gonna run blazingly fast, isn't it? Isn't it? Yes, obviously it's gonna run faster. Okay. So the point is that it leverages this parallelism in order to do your queries. So the data of your table is filled in these buckets. After dividing them into 60 equal parts, the buckets are filled. Those buckets are then distributed to the compute nodes. Number of compute nodes depend on how much DWU you have purchased. Queries are executed by these compute nodes on these buckets. The result is given back to the control node. The control node assimilates and collates the result and give it back to you. Parallel processing, distributed processing. But the entire game lies over here. You had your rows of the table, you divided the rows into 60 equal parts, and then you filled them into the buckets, distribution buckets or slots. 60 slots are there, 60 buckets are there. You can think like that. How did you fill these buckets? That is what intelligence is, right? So we ask a question that you fill the buckets, you fill distribution slots, distribution slots which are 60 in number. But how do you fill it? That depends on a property of a table. Every table has a property which is called as distribution slot. Yes, which is called as distribution slot, distribution property. Look at this, please. Let me show you our warehouse, and let me take you to the data, and let me take you to the workspace. Let me take you to our warehouse, SQL Pool 01. Let me show you the tables here. Here we grab the magnifier. And if you look here, see this. Look at the symbols. If you look here, please. If you pay a little careful attention to these symbols, you see that these are the tables inside the warehouse, and they have a little bit symbol going on here, right? This symbol is a symbol of the distribution property of this table. This table, wwi.date, is using a distribution type, distribution property set to replicate it. This wwi.innerJoinAGG, this is a symbol of round robin. Replicated, round robin. This is the symbol of hash distribution property, hash. This is round robin, this is replicated, this is round robin, and this is replicate, round robin, replicate, round robin, hash. What is this property? And why is it so crucial that they are trying to show you here as a symbol? Oh, that is so important that your entire warehouse performance of your warehouse depends on that. Okay, distribution. Okay, there are three types of distribution properties, as we told: round underscore robin, second replicate, and the third is hash. These are three types of distribution property. They decide how are the rows of that table are filled in the buckets. Rows will be divided into 60 equal parts, but how will they be divided and how will they be filled? Depends on this property. Round robin is used for loading from external sources. Yes, like your lake, external source like lake. So if you want to load the data from your lake to the warehouse, you will load it in the round robin table. RR is default. if you don't tell what is the distribution property of a table at the time of the creation of the table, DDL statement of the table, it is default. The table will default to RR. It is for loading activity, not for dimensional modeling. These are not for facts and dimensions. Okay, this is for your, not for dimensional modeling. Okay, it is for loading, not for dimensional model, which means these are not query tables per se, and these are loading tables, not query tables, not query tables. So if they are not query tables, then what? Don't place any index, right? So we generally use heap on them, no index. Heap, which means no index. Don't use any index, because we know that index improves the performance of select statement. Index does not improve the performance of inserts, updates, and deletes. On the contrary, the index can degrade the performance of inserts. And you see, it is a loading table, hence heavy insert. So high volume of insert, no index. But you may find some people placing a CCI, clustered column store index, clustered column store index on this. Why? Why are you placing a clustered column store index on it? When it is not for query needs, it's for compression. Because clustered column store index provides you clustered column store index compression and archival compression. Column store archival compression and column store compression. So if the size of the RR table, size of your round robin table is very high, right, of the orders of hundreds of GBs, okay, then place an index because you would like to do compression, column store compression, and because compression will be beneficial. Because of compression, you can do that compression. That's why. From RR table, now this is the most important one. From RR table, other dimensions and fact tables are created. Other dimensions and facts are created. Facts are created as per the ER diagram. Okay. Using what? Using TTAS statement. Treat as a statement. Create table as select statement. I will demonstrate it. Don't take anything. Create table as select statement. So what is round robin? Round robin is used for loading from external sources like your lake. It's default. It's not for dimensional modeling. It's not for query tables. It's for loading. Hence, it's not a query table. Heaps are used. Index is not used. But some engineers place a CCI on it when the size of the round robin table is of the orders of hundreds of GBs because of compressions. And from these RR tables, other dimensions and facts are created as per the ER diagram of a warehouse, as the modeling and the relationship needs you have. Using CTAS, create table as select statement. Yes. What are other kinds of distributions? Replicate. Now, this is for dimensional modeling, right? So, dimensional modeling. It's for dimensional modeling. Yes, it is query table, right? It is for your query tables. Now, what is it for? It is for small dimensions and facts, right? So it is for small dimensions. How small? Approximately 2 GB in size. Table cannot be more than 2 GB. General recommendation, it is approximately 2 GB. Less than equals to, approximately less than equals to 2 gigs. Very small tables, very small dimensions. Small dimensions table. How small? Less than 2 gigs tables. Small dimension table. Now it is a query table, so obviously what would you do? You will place a CCI on it. Mandatory, right? You will always always be placing a CCI on it. If there are no data types that don't support CCI, then you may place a clustered one, clustered index, not a clustered column store, clustered only. If certain data type you are not using, right? Bits and binaries and all those. And it can also be partitioned. So if you want to shard it, you can partition it. Okay, partitioning is also supported. Range right by values and range right for values and range left for values. You can place both of them, no problems. What we mean by replicate is, because the table is very small, it will be replicated, or you also say it in some other terms, broadcasted. Replicated or broadcasted to all the compute nodes. Each copy of the table will be given to everyone. Replicate, because the table is a small. Replicate. Then what is the last and the final one? The last and the final one happens to be, as you can clearly observe, hash. What do you mean by hash? What do you mean by hash? What we mean by hash is, first of all, it is also for dimensional modeling, but it is for large dimensions. Just reverse this sign and remove the approximate. Large dimensions and facts. Obviously, because it is a query table, you will place a CCI on it, clustered column store index, isn't it? You will place a CCI on it because it is a query table, and it is also be partitioned if needed by you. What do you mean by hash? You're going to have to give it a column of hashing. Look at this query of ours. Look at our query. We are performing a join on t1.a equals t2.b. Let's say t1 is a fact table and t2 is a dimension table. And I'm joining on this column A from t1 and B from t2. Wouldn't I prefer all the rows with the same value of A to be put in the same distribution bucket? Take a simplistic example. Let's say this is the table T1 and this is the column A of that table, and this is the table T2 and this is the column B of the table. Take an example. Let's say A has values. Take an example. A has values 101, okay, 102, 101, 102, 102, 103, 104, 105. Take an example like this. These are the rows in the A, t1.a. And let's imagine that I have some B's also here. In t2.b, I have some data. Okay, 101, 101, some more 101s. Okay, 102. These are the rows, right? 102. Then you have, let us say, 103. Okay, 103. Let's say these are the rows in the B. Okay, these are the rows in the t2.b. Would I not wish that all the rows that have the same value from both the table are put in the same buckets? 60 buckets are there. So let us say, take a simple example, buckets. Bucket B1, and take just two buckets. Bucket B2. Calculate the hashes. So calculate the hash of this. Let's say the hash comes out to be small capital A. This hash would also be capital A. This hash would also be capital A. This hash would also be capital A. Correct? All the rows with the same hash will be taken and put into the same bucket. Let's take this. All the rows with the same hash value would be put in the same bucket. Calculate the hashes here. Let's say the hash is B, the hash is B, the hash is B. Take all the rows and put them in the same bucket. Let's say in the bucket number B2, we put it in the buckets B2. We put it in the buckets B2. We put it in the buckets B2. Calculate the hashes C, C, and C. Put it in the same bucket. In any bucket you can prefer, which means you can write it to the bucket C, but they would be together. What it means is that all of the rows will be same. Go to the same bucket. Control node does this when you say hash table is there. Now, because all the rows are in the same bucket, join will be faster. All the rows of A are here, so I can join these tables. I can join all these rows. I can join all these rows. I can join all these rows because they are being separated intelligently already by hashing. Control node does. So hash is used for joinings, group by and joins heavily. Okay, it computes the hash. All the like hashes are put in the same bucket, and because they are already being partitioned into the same bucket, they are faster to join, right? Hash. So again, it is for dimensional modeling, query table, large dimensions, more than 2 GB tables and facts, obviously, because it is a query table, you're going to do a CCI on it. And partitioning range right for values and range left for values, both are available. And it is super important to use them properly. It is used for your joins, particularly for joins, right? When you do heavy end joinings, you would leverage hashing. With this idea about the dedicated SQL pool internals, that how it operates and what it has internally in it, it now becomes easier for us to start the loading activity into the warehouse. What are the loading technologies which we have already discussed? If we were to just revise that, loading technologies that we have already discussed. Number one, Synapse SQL connector. Synapse SQL connector that you have already seen. Its variation, PySpark JDBC, right? JDBC connector is also there, whose practice you can do later down the road. Polybase is there. Third is copy into statement. Bulk insert is also there, which is beyond the discussion of ours, but in case someone wants to do that, bulk insert you can. And last and final one is copy activity in the pipelines. Copy activity in the pipeline. These are the 5 ways loading technologies. This one we had seen in the module 4, in the previous module 4. This we will see now. This we will see now. This is, I will share an exercise if you want to do, because this writes it in the batches of 40200 rows. Okay. It's a batch insert, bulk insert. It's not for us at this moment. We're going to look at these polybase and copy into and this. Polybase, you know what is polybase, right? It's a data virtualization technology that was invented by Microsoft SQL Server 2016 onwards. SQL Server per se, the RDBMS product, does not know the protocols of HDFS, Amazon S3, Azure Data Lake. Polybase, as the name says, polybase, polyglot. Polyglot is a person who can speak more than 6 languages, right? So if you happen to be such a person, you are very different from rest of the common people. So if you speak more than 6 major languages like Spanish, Japanese, Chinese, Portuguese, Hindi, Hebrew, whatever, you speak more than 6 languages, let us say, then you are polyglot. What is an advantage? You could act as an interpreter between any two languages which you know. For instance, let's say you know Chinese and Spanish. So if there is a Chinese man and a Spanish woman, they are going to converse, you could act as an interpreter for both of them. So SQL Server is RDBMS product, although it now has a BDC configuration. Let's not go into that big data cluster configuration. It's a per se an RDBMS product, right? And when SQL Server wants to talk with other protocols, HDFS, DFS, Amazon S3, ADLS, data lake storage, Oracle, Teradata, SQL Server uses this technology, Polybase, to converse with other products because it cannot understand their protocols, right? So this Polybase helps SQL Server talk with them, read and write data to and from those external sources. So we're going to be obviously moving the data from a lake to the warehouse. Okay. So when you want to move the data from the lake to the warehouse, now lake, you know, it's a DFS, distributed file system. It's a HCFS, Hadoop compliant file system in the cloud. So when you're going to move the data from an HCFS to the RDBMS, which is data warehouse, SQL data warehouse, one of the way to do that is Polybase, which leverages data virtualization. What do you mean by that? You know that, right? External data source, external file format, and then external table. Primarily, these are the three metadata objects that are mandatory. Apart from it, also you can create external table. Others are also there as per your needs. You may have to create them, create a master key, create a database scope configuration, create certificate, create symmetric keys, whatever. You may need other objects, but these are the three mandatory objects, metadata objects, data virtualization objects. Polybase is a champion at large volume of data because it uses parallel DMS, parallel data movement service. One-off loading, initial loads. So when you lay down the foundation of new warehouses, it is typically recommended to be used, Polybase. Copy into is a more modern statement. Copy into statement is also there. But its limitation as far as the documentation also lets us see is source can only be a lake. In Polybase, source can be various things: Amazon S3, Lake, HDFS, Oracle, Teradata, and so on and so forth. Multiple sources are supported in Polybase. Copy into statement supports a lake. Source can be the lake only. But it is very concise, very concise, very concise and comprehensive. Very concise and comprehensive, and can handle comprehensive means you don't have to author all these things. Data source, file format, nothing required. Very concise, very comprehensive. And has one more advantage where it beats Polybase. It can handle custom row delimiters, row and column delimiters, which means row and column delimiters in your flat files. We'll see it when we will demonstrate. And copy pipelines, you know, it's automation. Bulk insert, right? Inserts the data into the batches of 402,000 rows at a time.
So guys, if you liked our video, then do give us a thumbs up. But if you really want to learn more about the particular topic we discussed, then we have something really special for you. We have our free class on Microsoft Azure Data Engineer certification, that is DP203, along with some question and answers, where we'll be discussing about why is everyone working on data, importance of some Azure services you should learn, and many more things. So for that, all you have to do is just log on to k21academy.com/Azure DE02, and after that you'll be seeing a screen like this. Just click on book your free seat now. Select your event date whenever you're available. Reserve your spot by adding your name, your email address, and your phone number, and you'll be getting all the updates via mail. You'll be seeing this kind of window on extreme right, so you can save this link, add to your calendars, and I'll see you in the free class. Till then, keep hustling and take care.